Okay, I just stopped this part. The critical section is the region that at that region that process is need to use the shared memory. Okay, but to be sure that not more than one process enters to critical section at the same time. What does it mean entering at the same time to the critical section? It means if more than one process are trying to use the critical section at the same time, it means they are trying to use the shared memory at the same time. And this will cause race condition, which we don't want it. So we have to develop a mechanism to avoid the critical section. Okay, someone's yes. Okay, think about that. All the processes are tries to enter. I mean, if all processes, all four processes are inside their critical sections at the same time, it will cause a race condition. So to synchronize the cooperative processes, what was synchronization? I mean, we are just ensuring the order of execution. Okay, this one should be first, this one should be second, something like that. If they are working corporately, I mean, they are just one of them is producing something, some of them is consuming the same thing. They are cooperative processes. So for synchronization, one problem is critical section problem, and we have to solve it. So we have to find a solution for that. So we have some requirements for synchronization. Okay, or in other words, I can say to produce a mechanism to ensure synchronization, we have some requirements, or we have some criteria. One of them is mutual exclusion. The other one is progress. The third one is bounded weighting. And the fourth one is architectural neutrality. So these are our requirements. So I will explain each of them in next slides. So let me to come to the previous slides again. So what we said, we have to solve the critical section problem. Okay, so this is a problem just in front of ensuring synchronization. And to ensure synchronization, to ensure that processes are executing one after the other. No one is entering the not more than one process entering the critical section at the same time. We have to ensure synchronization. Okay, the first one we had I read 4 criteria. The first one is mutual exclusion. What is mutual exclusion? Actually, it is related to critical section example. So if 2 processes, process A and process B, are using same shared object. So process A and process B cannot be use same shared object at the same time. Think about that. This is a timeline, as you see. Sorry. This is a timeline. Think about that. The first process that using shared object is process B. Okay. But when it stopped to use shared object, then process A start to use it. And when process A finished to use shared object, process B starts to use it. Okay, and again same thing. So they are not using the same shared object at the same time. Okay, and this is called mutual exclusion. This is called mutual exclusion. So the one of the criteria is mutual exclusion. So
also,
yes.
What will happen if these 2 processes will use the same shared object at the same time?
Your voice is coming very bad. I don't understand.
I said if this process 1, process A and process B use the same shared object, what will happen?
If process A and process B, yes.
Yes, use the same shared object at the same time.
What will happen? Okay. What will happen? Think about that. Process A is doing some operation at that time. Let's say it is calculating something by using that shared object.
Yes.
And it is assuming that the results, how can I explain to you? How can I explain to you? Let's say, just 1 second. Let's say this shared object have 5 as value. Okay.
Yeah.
And here in process A, let's say we have let's say the shared object name as A. Okay. And process A will, for example, say A is A plus 5. a kind of critical section.
Okay.
Okay. And let's say here A is A multiplied by 5. So if this one execute first, okay,
Yeah.
shared object value is 5, okay, 5 plus 5 is what? Is 10. So new value of shared object will be 10.
Yes.
Okay. And then let's say process B is executed. 10 multiplied by 5 will be 50. So new value will be 50. Okay. But if let's say both of them, I erase everything, but anyway, if both of them are trying to enter at the same time, this one will do, I mean, what did I write? A is
Addition.
A
Equal
plus
plus
5. And this one will try to make A is A multiplied by 5. 1 second. So let's say this one start first. This one start first. How can I say, the values will be confused. So normally, for example, process A will expecting to execute first, and the results of process A, after process A put the result into shared object, process B will take the value and continue. But if both of them will try to enter at the same time, the values will be confused. I mean, which one's value will be what? It will be a chaos there. So it will produce unexpected results. That's why we don't want, we want to ensure the order of execution. And also we need to ensure that only one process can use shared object at once.
Okay. At that case, we cannot talk mutual exclusive in that case, right?
Your microphone.
Yes, I can.
His microphone.
You know that your headphones are not
laptop.
good. Remove them, bro.
Hello, sir.
Hello.
I said in that case, we cannot talk about mutual exclusive, right?
If both of them are using shared object at the same time, it is not mutual exclusion. But this is not something correct in operating systems. So we can't understand which process will produce which product.
Okay. Okay, move on.
Okay, thank you. Okay, one requirement is mutual exclusion. Okay, it is explaining the same thing. Let me to read and continue. By mutual exclusion, we mean that if one process is executing inside critical section, then the other process must not enter in the critical section. So only one process can enter to the critical section at once. So mutual exclusion is just avoiding this thing. I mean, if you supply mutual exclusion, you will also solve the critical section problem, or sorry, race condition problem. Okay. The second one, so the first one is related to shared objects. I mean, we have to ensure that only one process can use the shared object at the same time. The second one is progress. So progress means if one process doesn't need to execute into critical section, then it should not stop other processes to get into the critical section. It is like one process is just wants to enter to critical section, or how can I say, the order is, for example, says that, okay, P1 needs to use the critical section, but P1 doesn't enter to critical section. Why? One reason may be it is waiting for some input-output operation or some results from another process. After it takes that result, it will take that result and enter the critical section, something like that. It is like you are ready to go to school, you are waiting for bus, but when bus comes, you can't enter because you are waiting your, for example, friend to bring you your pocket because your money is inside. Okay, so if the bus is a kind of critical section, your time is come, you can enter to bus, but because of you don't have money, you can't enter. Okay, you have to wait. So it is something like that. Sometimes one process have right to enter to critical section, but it can't enter because it is waiting for another thing. So if this kind of situation happens, you have to just make a space, the process have to make a space to the others to continue. Like in the bus example, think about that. You are just waiting inside the bus. You don't have any money, but you are waiting, just enter the bus, and you are waiting your friend to bring you the money. So other people cannot enter to the bus because you are waiting there, and you are waiting because you have to pay money to the driver and then sit. So it is if there is a kind of situation, this kind of situation, there should be a mechanism that, okay, says to you, okay, go out, take the money and come back, something like that. So if one process will not enter to the critical section, it will not avoid the others to enter. I hope you get me. So yes, I will explain it with an example. The progress example. Suppose in the closed section of a departmental store, a boy A and a girl B want to use the changing room. Okay, so we can just call changing room as critical section. Okay, so both boy A and girl B need to use the changing room. Boy A wants to go first. Okay, boy and girl, they want to use the changing room, so both of them need to use the critical section. And boy A is just maybe come before girl B, so boy A will use the critical section first. Okay, so since boy A wants to go first, girl B has to wait till boy A comes out. Girl B should wait boy A to try the clothes and come out. Okay, boy A decides to use the changing room first, but cannot come to the decision as how many clothes to take inside with him. So boy A wants to enter the changing room, but he don't know which clothes he will take. So it is something like a process can enter to the critical section, but still waiting for some product to take and then enter there. So in this case, what will happen? Maybe boy A will wait forever because maybe he will never decide. And girl, because of boy A is just standing in front of changing room, I mean critical section, girl B will never use the changing room. Okay, so the progress should solve this problem. We'll say boy A, okay, just sit there, think about what you have to try, and then come back. Okay, so progress is a kind of mechanism in operating system that ensures that this situation will not happen. I hope you got me what I am trying to say.
No.
No, you didn't. Okay, just give me 1 second. I have to put my power plug to my laptop and come back. Just 1 second.
Claire, 1 minute. Bitaka, Claire.
ZDC++ là, c'est sur combien midterm? 40, 50 ou bien 100?
Elle a mis ça.
Elle a mis ça de Zan.
Après, c'est fini.
300.
Hein?
Zan,
Ouma, toi, tais-toi ici avec ton micro là. Hein?
Alphonse,
Hein?
Zan,
c'est fini.
No. He said
Zan,
he wants to plug in his
Zan Mendor
laptop.
comme ça. Il faut
Ouais, je
dormir.
ne dors pas, je suis là. Je travaille. Pourquoi tu appelles mon nom comme ça?
C++ là, il a noté ça sur 100 ou bien sur combien? Tu sais, moi, ce que j'ai eu là-bas, là, c'est
Moi, je
Moi,
sais
j'ai
pas,
mis
je vais
dans
aller checker. Je vais aller checker.
Moi, je vois 159 là-bas. Je sais pas si c'est sur 200 ou...
Ça, c'est
Amana quoi?
Et non, ne c'est pas le professeur est là, non. The teacher is here, bro.
People are making noise, bro.
Which noise? It's break time.
Okay, can you re-explain this thing to me because I didn't understand that part.
Okay, I'm here now. Yes, let me to start from the beginning. Let me to explain first progress.
Yes, sir.
Okay. Progress. So the second criteria is progress. Look, when a process have can use the critical section, if it needs another thing, I mean, maybe that process at that time needs some input-output operation, take some results or something like that. So if at that time process cannot enter to critical section, it should be a mechanism to say that process, okay, you wait, and the other process will continue to use the critical section. Otherwise, maybe that process, that waiting let's say it is waiting a result from another process. Maybe it will take the result and after that can continue to execute. So maybe that result will never comes. In this case, it will be a kind of deadlock. So the system will be locked forever. You need to restart the system. So to avoid this, some mechanisms should say that the process that waiting and not entering to critical section, okay, wait for the product that you are waiting, and when it is come back. Okay, like the example that I said to you, you are waiting for to enter the car, the bus, school bus. You prepared, you have everything to enter, but you have something missing. What is missing? You forgot your money. So when your bus comes, maybe you enter the bus, but you're still waiting for the money that your friend will bring to you. While waiting your friend, you are standing just in the entrance of the bus. You are waiting for your friend to bring you money, and when he brings you the money, you will bring to the driver and you can just sit down. But you are just standing in the entrance of the bus and no one else can enter to the bus if we think that bus is a critical section. Okay, because of you are waiting for money, you can't enter to the bus. You are waiting there. So some mechanism should say to you, okay, just leave the car, leave the bus, and wait for the money to come, and then you will enter to another bus. Or maybe bus driver say, okay, I will come back later, something like that. Okay, so this is called progress. If one process cannot use critical section, it should give space to the others that wants to use critical section. And we have an example here, just an analogy, which we have a boy and a girl that wants to use the same dressing room. And if we say that dressing room is like a critical section, think about that. Girl B knows what she's going to try, but boy A comes first, and boy A wants to enter to the critical section, the dressing room, changing room. So, but boy A didn't decide yet what he's going to try. Okay, just he stand in front of changing room and waits. He's thinking what he's going to try. So boy maybe think forever, I mean, what he's going to try. And because of the boy, girl B will never enter to the critical section. Did you got me now?
Yes, sir. Yes, sir.
Yes.
Okay, so we should, a mechanism should be there that say boy A, okay, sit down and think what you are going to try, and let girl B to use the dressing room. Okay, so the programs should continue to use the critical section, and this is called progress. This is the example of just with an analogy. So, as I told you, if, I mean, it will be something like that. A boy is waiting in front of the dressing room. System should give some time to it. Okay, whatever, maybe 5 nanoseconds, let's say. So it will give 5 nanoseconds. If process 1 will not enter to the critical section, so it will just say, okay, just leave there and wait here until you just find out what you are going to try. So otherwise, what will happen? A deadlock may occur. Okay. Okay. So let me to, as I told you, we have 4 mechanisms: the mutual exclusion and the progress are the primary importance. Okay, so these 2 should be, how can I say, should
Respect.
be succeeded. Okay, they are primary importance. And we have 2 more: bounded weighting and architectural neutrality. I'm going to explain these 2. So bounded weighting is we should be able to predict the waiting time for every process to get into the critical section. So just independently from the from one process is waiting for another thing, something like that. But think about that. One process is waiting for critical section, but time will never come to it. So we have to just give a limit to it. Okay, so it is something like, okay, you went to it is something like, let's say you are waiting in traffic inside the car. Normally that road should be open in 1 minute. Okay, there's a traffic, but you in 1 minute you have to start to move. But maybe 10 minutes passed and still the cars are not moving. So in this case, you have to decide what you have to do. Maybe you have to just find another way. So here it is similar. If a process is waiting so long for enter the critical section, we have to limit it, I mean, in a time. we may say, okay, if a process is waiting maybe 30 nanoseconds, so after 30 nanoseconds, it should stop waiting there. Okay, so this is called bounded waiting. So this is for avoiding to process not endlessly waiting for getting into the critical section. Okay, so this is bounded waiting. The last one is architectural neutrality. It means that if you develop a mechanism that all these four criteria will be ensured, it should be ensure architectural neutrality as well, which means that if you find a solution in one computer architecture, it should be work in another computer architecture as well. Simply, I can say if you found a solution in, how can I say, in a Windows computer, it should be work in Linux computer as well. This is not architecture, but how can I say? Maybe AMD. Let's say if you find a solution in AMD architecture, it should be work in Intel as well. So in different computer architectures, it should be work. Okay, this is called architectural neutrality. So these four mechanisms should be ensured. And we will see log variable and TSL as a solution of these problems. I mean, critical section problem. But there, as I told you, there are more mechanisms that ensuring that, but their programming language is very tough to understand. I will just, and this is not a programming course, so I will just put the simplest ones. I will finish the lecture here. Time will over. And continue from this point on Thursday. But as I told you in the beginning of the lecture, I will ask a few questions related to this topic.
Okay, sir. Thank you.
Not at all. I will write to WhatsApp group. Okay, we don't have enough time.